Alrighty, this is going on page 73 when we are done. So we have solved exponentials getting a common base. We have solved logs using exponentials, and now we're going to solve exponentials using logs, right? So if using a common base is not possible, like that's the road you want to go down first of all if you can, then exponential equations can be solved using logarithms. So you isolate the exponential expression or expressions if there's more than one. Take the log of each side, then expand the logarithms if necessary using the power rule, and solve and check for extraneous solutions. All right, so here, if I want to get x out of the exponent up here, again, I can't get a common base because it's 80, not 81. I can take the log of both sides because whatever I do to one side, I have to do to the other. As long as it's balanced, I'm good. Now, I could take the log base 3 of both sides because log base 3 of 3 is what? 1. Log base 3 of 3 is 1, right? But then I'd have log base 3 of 80, and then I'd have to do, get my use my change of base formula. I don't want to do all that. So really using log base 10, which is there's a button on a calculator for that, and a log, natural log, then either one of those is fine. Since moving forward, oh my lord. Since moving forward, natural log is really what you're going to use most in calculus and beyond. Natural log and E, we'll just use that one because it really doesn't matter at all. But if I want to get this out of the exponent, I'm going to take the natural log of both sides. Natural log of 3 to the x power equals the natural log of 80. What happens to that x? Comes out front. So I get x times the natural log of 3 equals the natural log of 80. And then what do I do to get x by itself? Divide by the natural log of 3. So x is equal to natural log of 80 over the natural log of 3. Then you just type that in your calculator. And x equals 3.989. Make sure you're actually getting those numbers. Because it could be whatever you wanted. It could be regular log. You could use either one. You could do log. If you want to type in log of 80 over log of 3, you'll get the same answer. It doesn't matter because whatever you do to one side, you do to the other. And we're just using natural log because, like I said, that's the one you need to be more familiar with anyway. Not that it matters. Everybody okay with that? Easy enough? All right, so let's jump to number 4. So I have an exponential that I cannot get a common base with, so I'm going to take the natural log of both sides. So the natural log of 1/3 to the 2x minus 5 power equals the natural log of 120. So now I have an exponent that's going to come out front using my power rule, but it has 2 terms, so it has to be in parentheses. 2x minus 5 times the natural log of 1/3 equals the natural log of 120. Now at this point I could distribute, but I don't have to, and so I don't want to. So instead, what could I do? Divide by the natural log of 1/3. So I get 2x minus 5 equals the natural log of 120 over the natural log of 1/3. Then what would I do? Add 5. So 2x is equal to the natural log of 120 over the natural log of 1/3 plus 5. Thanks. And then divide by 2, right? Well, I can divide by 2, but I'd have all that mess all over 2, and there's nothing wrong with that. But dividing by 2 is the same as multiplying by what? 1/2. So x is equal to 1/2, but then big old parentheses, natural log of 120 over the natural log of 1/3. Oh, that's 13. 1/3 plus 5, then close my parentheses. I can type all that in just like that. So I'll have my fraction here, and then I can even have a fraction and a fraction. It'll all work out nicely. Yes, anytime you take the log, it's going to open the parenthesis, and then you have to close it before you can move. Otherwise, you're going to get an error message. So what do we get here? Good. 0.321. All right. What questions do we have? Anything? You'll learn to look at the sign. All right. Let's look at number 5. So can I start by taking the natural log of both sides? No. I'm going to have to move the 25 first. So I get e to the 3x power equals what? 83. So now I can take the natural log of both sides. Natural log of e to the 3x equals the natural log of 83. So 3x times the natural log of e equals the natural log of 83. So what is the natural log of e? 1, right? Natural log of e equals 1. So basically that just turns into 1. So I really have 3x equals the natural log of 83. So x equals the natural log of 83 over 3. Yep. 1.473. Yes, make sure that's really what you... No, yeah, it's the natural log of 83 all over 3. Yes. Yes, did you not get that? Oh, you did. All right, are we good so far? What questions do you have? Anything? How would you know if what? Oh, that's a good question. Well, then you could, so let's say, if you have, do you still have this answer in your calculator? Okay, so then you could store it. One way to do it, I got to look at the buttons. So you hit Shift and then recall, which is right above 7. I think you did. And then X, like you don't hit alpha, but just the right parenthesis, which is X. Okay, and so now it's stored in X, right? Okay, then you could just substitute into here. Just do literally e to the 3 times x power, and you should get 83. That won't work out if you don't store it. It's not going to use the whole thing. That makes sense. Yeah. Oh yeah, to get it back after. There you go. And then hit equals. Uh-oh. That's okay. Let's see what we did. Okay, you don't have that. You didn't actually store it in X. That's why. So here, do natural log of 83. And then divided by 3. There you go. That's fine. So then we're going to do Shift, recall, and then just hit the right parenthesis. Yeah, no, don't do alpha. Just the right parenthesis. So now it showed you it's stored in X. Now if you do e to the 3x power, or 3 times x power. There you go. Okay? That's a way to check yourself. All right, good question. Anything else? All right. Yeah, on these calculators, when you go to store, you don't hit alpha X. You just, once you're ready to store, you just hit the letter and it kind of knows that you're going to do that. On the 83s, you do have to do the alpha thing. All right, let's flip this over. Number 7. What will be the first thing I do on number 7? Add 1. So I get 2/3 times 2 to the x minus 6 power equals 42. Then what would I do? Multiply by 3/2, right? So those cancel out. That's why we did it. So we get 2 to the x minus 6 power equals what? $63. I already did that. That's all right. So I'm going to take the natural log of 2 to the x minus 6 power equals the natural log of 63. Then x minus 6 times the natural log of 2 equals the natural log of 63. Then what would I do? Divide. So, oops, I don't need the parentheses anymore. X minus 6 equals natural log of 63 over the natural log of 2. And then, oops, equals. Then x equals natural log of 63 over the natural log of 2 plus 6. Say that one more time. No. No. You have to take those separate. That means two different things. All right. So if you got an error, you probably lost a parenthesis somewhere. But if you are getting errors or you're not getting the right numbers, you need to say something so I can help you before we move on. All right, what questions do we have? Anything? We good? Okay, so now again, here I could have distributed, right? I just chose not to, which is fine. There will be times where you're going to have to distribute, whether you want to or not. Are we having issues here? Oh, 3. And then equals. And you have to hit AC. There you go. All right. Number 9. So I have two exponentials. They're isolated on either side. Do not have a common base, so I cannot just take the exponents out. So I have to take the log of both sides. So the natural log of 2 to the x plus 5 power equals the natural log of 3 to the x minus 2 power. So now I can use my power rule and bring my exponents out. X plus 5 times the natural log of 2 equals x minus 2 times the natural log of 3. Now, on the one before this, at this step, we divided. I could go ahead and divide by the natural log of 2, but the problem is, yeah, I could get x by itself over here, but I have an x over here as well. So the only way I'm going to be able to get my x's together is if I go ahead and distribute. So here I have to distribute. So I'm going to get x times the natural log of 2 plus 5 times the natural log of 2 equals x times the natural log of 3 minus 2 times the natural log of 3. So just like anything else you have ever solved, you are trying to isolate the variable. So that means you need to get everything with your variable on one side of the equation and everything that doesn't have the variable on the other side of the equation. So I'll move my x's to the left. So this is good here, but I'm going to subtract this and get x times the natural log of 2 minus x times the natural log of 3 equals, and then I'm going to have this moved over here. So I'll get negative 2 natural log of 3 minus 5 natural log of 2. So all my x terms are on the left-hand side. Everything that's not an x term is on the right-hand side. Okay. What questions do you have about that? We're all good? Now, what am I going to need to do to get x by itself? What? Factor out the GCF, right? Both of these terms have an x in there. So I need to factor that out. And that's going to leave me with the natural log of 2 minus the natural log of 3 equals negative 2 natural log of 3 minus 5 natural log of 2. Then what do? Divide. Now I divide. So I get x equals negative 2 natural log of 3 minus 5 natural log of 2 over natural log of 2 minus the natural log of 3. Anything I can cancel out here? No. So I just type that in just like it is. That is the number you should get. So if you don't get that, let me know or see if you can figure out why. Laura, do you have a question? You seem stressed. Okay. But do you see how we distributed here from here? Okay, and then I took all of that, then I moved this term over here, and I moved this term over here because I need to get all my x's over here and stuff that's not x's over there. Okay, and then we factored out that x. So. All right, so what questions do we have? Anything? All right. Okay, I'm sorry. This is a 7. Did something wrong. Okay, we don't have it in a fraction. So what you did was you said 2 minus this divided by whatever the first thing is you had, and then you add something at the end. So basically it's your order of operations there. Either you need to add a ton of parentheses or put it in a fraction. That's why these calculators are so awesome. I know they really are. About how to type things in and make it so much better. Get it? Okay, awesome. All right, so I'm gonna walk you through one more of these. I'm gonna take the natural log of both sides. So the natural log of 8 to the 2x minus 1 power equals the natural log of 5 to the x plus 3 power. So bring that out. 2x minus 1 times the natural log of 8 equals x plus 3 times the natural log of 5. So in this situation, I'm going to have to distribute. So this gives me 2x natural log of 8 minus the natural log of 8 equals x times the natural log of 5 plus 3 times the natural log of 5. Then you get all your x terms to the left. So 2x natural log of 8 minus x natural log of 5 equals 3 natural log of 5 plus the natural log of 8. Got all my x's on one side, everything that's not an x on the other side. Then I have two terms that have x in it, not like terms, so I have to factor it out. Get x times 2 times the natural log of 8 minus the natural log of 5 equals 3 natural log of 5 plus the natural log of 8. Pretty much this just looks way worse than it really is, and you just got to make sure you don't lose anything anywhere. Then we divide, so x equals 3 natural log of 5 plus the natural log of 8 over 2 natural log of 8 minus the natural log of 5. Then we type it in. What questions do we have? If you don't have any questions, then you can go ahead and start on number 12. If you're still working on that one, that's okay. I'll come by and check it in just a second. Did you lose something somewhere? Oh, addition in the numerator. So you can just arrow to the left, and you can go edit it. You don't have to. Yeah, number 12. Go on to number 12. Number 12, yes. Were there any questions on 10? Or I got that one figured out. Okay. What did I do? Oh, minus 5. Thank you. 5 and 5 right there. That'll work. Okay. And we get negative 0.353. Use the right stuff. That's where I had to squeeze my 5 in that I left off. And there are places in here, like when you subtract two logs with the same base, you can condense them and make it into what? When you subtract two logs with the same base. Yeah, so I can change it to division, right? Or when I add two logs with the same base, I can make it into multiplication. So there are places in here where you could condense, but you don't need to, and it's just extra steps. Like, it's just not necessary. Okay. All right, we good? What questions you got? All righty. So then go ahead and get started. You got lots of time to work.